Let n and d be fixed integers, then how many integers m are there such that n square plus md is an exact square? Let k be a positive integer, then n plus kd whole square is equal to n square plus 2nkd plus k square d square, and that is equal to n square, and if you take d common from these two terms, it becomes d multiplied by 2nk plus k square d, or n plus kd whole square is equal to n square plus 2nk plus k square d multiplied by d. Let us call it equation 1. The left hand side of this equation is a perfect square. Therefore, the right hand side is also a perfect square. Now the right hand side is n square plus 2nk plus k square d. This is of the type n square plus md. This n square is there, and in place of md we have 2nk plus k square d multiplied by d. Therefore, m is equal to 2nk plus k square d. Even though n and d are fixed integers, there is no such restriction for k. K can take any integral value, and for the given values of n and d, m will automatically take a new value as per the equation m is equal to 2nk plus k square d. Then n square plus 2nk plus k square d multiplied by d will take a corresponding integral value. Since n square plus 2nk plus k square d whole multiplied by d is equal to n plus k d whole square, this integral value will be a perfect square. Before going any further, please like, subscribe, share and hit the bell so you can be immediately notified for new uploads. It is completely free and only takes a few seconds, and you can always unsubscribe later if you want to. More importantly for me, if you like, share and subscribe, it would encourage me to make and post new videos for you to view. Also, if you know about any interesting problem that you would like me to solve, please upload it in your comments. Without further ado, let's proceed with the rest of the video. The argument is as follows. N and d are given integers. K can be any integer. Then m is equal to 2nk plus k square d is an integer determined by the values of n, d and k. Hence, n square plus 2nk plus k square d multiplied by d is equal to n square plus md is yet another integer. But n square plus 2nk plus k square d multiplied by d is equal to n plus kd whole squared. Therefore, n square md is equal to n plus kd whole squared. Therefore, n square md is a perfect square. Hence, k can take any integral value, and for each such value there will be a different m and there will be a different perfect square. Since k can take an infinite number of values from 1 to infinity, so can m. Therefore, there are an infinite number of integral values of m for which the term n square plus md will be a perfect square. We will now take a few specific cases to demonstrate the above conclusion. We have taken arbitrary values for n and d, that is n is equal to 5 and d is equal to 3, to show that for each and every integral value of k, the term n square plus md is a perfect square. We have taken n is equal to 5 in all the cases, d is equal to 3 in all the cases. We have given different values of k, 1, 2, 3, 4, etc. and we have chosen certain random values 11 and 17 to show that the same thing happens for those random values also. Then if n, d and k are known, then the value of m will be 2nk plus k square, which is tabulated. When k is equal to 1, it is 13, k is equal to 2, it is 32, k is equal to 3, it is 57, k is equal to 4, it is 88, k is equal to 11, it is 473, and k is equal to 17 is equal to 1037. For these values of m, the values of n square plus md will be 64, 121, 196, 289, 1444, 3136. And each of these values is a perfect square. For example, 64 is a square of 8, 121 is the square of 11, 196 is the square of 14, 289 is the square of 17, 1444 is the square of 38, and 3136 is a square of 56. Hence, let us reiterate the conclusion that there is an infinite number of integral values of m for which the term n square plus md will be a perfect square. This is the answer. Thank you.